Hello students, welcome to Saurav Sir's classes. The question is, for n greater than is equal to 1, let an is equal to 1 by 2 squared plus 2 by 3 squared plus n by n plus 1 squared and bn is equal to c0 plus c1r plus c2r squared up to cn into r to the power n, where mod ck less than equal to m for all integer k and mod r less than 1. Then option A, both an and bn are Cauchy sequences. Option B, an is a Cauchy sequence but bn is not. Option C, an is not a Cauchy sequence but bn is a Cauchy sequence. And option D, neither an nor bn is a Cauchy sequence. Well, we have been given that an is equal to 1 by 2 squared plus 2 by 3 squared and up to n by n plus 1 squared. Now this can be written as 2 by 2 squared plus 3 by 2 squared plus up to n plus 1 by n plus 1 squared minus 1 by 2 squared plus 1 by 3 squared up to 1 by n plus 1 squared. So this becomes 1 by 2 plus 1 by 3 up to 1 by n plus 1 minus 1 by 2 squared plus 1 by 3 squared plus 1 by n plus 1 squared. But half plus 1 by 3 up to 1 by n plus 1 is not a Cauchy sequence. So an is not a Cauchy sequence, and checking for b, bn is equal to c0 plus c1r plus c2r squared up to cn r to the power n. Now since mod r less than 1, bn is Cauchy as bn less than equal to m 1 plus r plus r to the power n tends to m by 1 minus r. So option C is the correct answer. That is, an is not a Cauchy sequence but bn is a Cauchy sequence. The next question is, let f be a continuous function with f1 is equal to 1. Define capital Ft integration fx dx from t to t squared. Then the value of capital f-1 is, we have been given that the function is continuous with small f1 is equal to 1. Now capital Ft is equal to integration fx dx from t to t squared. Now this can be written as integration fx dx from 0 to t squared minus integration fx dx from 0 to t. Now therefore ft becomes ht squared minus h0 minus ht minus h0. So I am left with ht squared minus ht. Now differentiating with respect to t on both sides, we get f dash t is equal to h dash t squared into 2t minus ht. So this is equal to 2t into f t squared minus ft. Now putting t is equal to 1, we get f dash 1 is equal to 2 into 1 into f1 squared minus f1. So 2 into 1 into 1 minus 1. So 1. Therefore the correct answer is option C. The next question is number of real solutions of the equation x to the power 7 plus 2x to the power 5 plus 3x cubed plus 4x is equal to 2018 is. So the equation is x to the power 7 plus 2x to the power 5 plus 3x cubed plus 4x minus 2018 is equal to 0. Now if we place x is equal to 0, we would get f0 to be minus 2018. Now f dash x is equal to 7x to the power 6 plus 10x to the power 4 plus 9x squared plus 4, which is greater than 0 for all x greater than 0, or rather for all x. Since we have all the powers as positive terms, and also since limit x tends to infinity, fx is equal to plus infinity, therefore f has only one real root. So the answer is option A, that is 1.